Okay, pause this and read the question. This sounds trickier than it really is. All right, I hope you've done that. All right, now what the question is asking for is for us to find their distance at 5 seconds and see who has the biggest distance. Remember, distance is the derivative or the antiderivative, the definite integral from A to B of speed, the absolute value of velocity. So when you read this, you might think, oh, I got to figure out, you don't have to. That's always going to be positive. That's always going to be positive. Cosine goes from -1 to 1. Cosine plus 10 is always going to be positive. So I don't have to worry about absolute value here. Both of these displacement vectors will always be positive. So let's find out James' distance. That will be the definite integral from 0 to 5 of 5 plus 2t dt. Don't forget your dt there. Every time you write an integral, you have to write a differential here, and it's always going to match whatever your variable is. The antiderivative of 5 is 5t. Remember, we're not doing derivatives, we're doing antiderivatives. The antiderivative of 2t is t squared. So my exponent was 1, it went up to 2, and then I divided by the new exponent. So what I really had was 2t squared over 2, but then these 2's cancel. So that's just t squared. Evaluated from t equals 0 to t equals 5. Now you can check this. How do you check this? Take its derivative and see if you get this back. The derivative of 5t is 5. The derivative of t squared is 2t. All right, now we plug in. It's always top minus bottom. When you're doing a definite integral, your answer is just going to be a number, and it's top minus bottom. So we plug in 5. So 5 times 5 plus 5 squared. So I replaced all the t's with 5 minus, and then in parentheses, replace all the t's with 0 because 0 is on the bottom. I mean, that's obviously just 0 there, right? So we get 25 plus 25, we get 50 meters. Are we in, no, feet. We're in feet per second. So this will be 50 feet. That's how far James went. What about Kathy? How far did Kathy go? So we're going to have the antiderivative from 0 to 5 of 10 plus cosine of pi over 2 t dt. Now we're going to have to, we haven't done integration by substitution yet. We're going to have to kind of work our way through this antiderivative. We're going to have to think about it a little bit. And then in the next set of videos, I'm going to teach you integration by substitution, which is really what we're doing here. This guy's easy. The antiderivative of 10 would just be 10t plus. Now let's think about this. Whose derivative gives us a cosine? So here we're just kind of thinking out loud. Well, we know that the derivative of sine of t is cosine of t. So the antiderivative of cosine is sine. But notice I've got a pi over 2 here. Well, the derivative, you might think to try this, the derivative of sine of pi over 2t would be cosine of the same thing. Derivative of sine of anything is cosine of the same thing times the derivative of what's inside. The derivative of pi over 2t is pi over 2. Remember, pi over 2 is just a number. The derivative of 7t with respect to t would just be 7. The derivative of pi over 2t is pi over 2. But we're getting closer. Like, remember, I'm trying to go backwards. If I had this sitting right there, I would be done. I got this extra pi over 2. Well, what if I just multiply both sides here by 2 over pi? What is the derivative of 2 over pi times sine of pi over 2t? Remember, we're just kind of trying to work backwards here. I want to figure out whose derivative would look exactly like this. And I think we've got it worked out here. The 2 over pi, that just comes along for the ride. Derivative of sine of anything is cosine of the same thing times the derivative of whatever's inside. Derivative of a constant times t is that constant. Oh, but now look, the pi over 2 and the 2 over pi, those cancel, leaving exactly what I was trying to get. So if this guy's derivative is that, then this guy's antiderivative is that. So we get 2 over pi times sine of pi over 2t, evaluated from 0 to 5. Okay, so this will be plug in the top for all your t's. Remember, these are t equals because I was integrating with respect to t. If this were a w, then these would be w equals. If this were a d y, then these would be y equals. Whatever your differential is here, that's the variable you're integrating with respect to, and that's who you're plugging these in for. So plugging in t equals 5 to everybody, all the way across, I get 10 times 5 plus 2 over pi times sine of, that'll be 5 pi over 2. Minus, plug in 0, I get 0 minus 2 over pi times sine of 0. Sine of 0 is just 0. This whole thing here is just 0. Now, what's this? What's sine? So let's come down here. That'd be 50, right there, 10 times 5, plus 2 over pi. I'll just rewrite this, sine of 5 pi over 2. What's sine of 5 pi over 2? Let's think about the graph. Here's pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. That's the graph of sine. Sine of 5 pi over 2 is just 1. So my final answer, Kathy's distance, will be 50 plus 2 over pi. And we can get our calculator out and see what that is approximately. But it's more than 50. Kathy's going to win this race. She's going further. Let's see, where's my pi? About 50.64 feet. So Kathy went further. Because the question was who went further in 5 seconds. Okay, that's a good place to stop that one.